Okay, thank you very much. Thank you very much, Derek, and the Iron Earth community for this opportunity to present the software that we've been developing. It's called Survey Analysis via Visual Exploration, or SuAVE, and it's a free system that you can use to publish your own data and explore the data and share it with others. Most of my presentation will be a live demo, and I also have a PowerPoint that I will refer to from time to time, and you will be able to see that after the webinar, because the PowerPoint will have all the links that I will show during this demonstration. And of course, live demos are often tricky, many things can go wrong, so not without some trepidation, let's get started. So SuAVE, we've used it for exploratory analysis of data of different types. Some examples are here on this title screen. For example, in biodiversity, this is a picture from Florida Museum of Natural History that has a very large collection of specimen data and images in archaeology. This is example from excavations in Negev. You can analyze it. You can use it to analyze data in art history. Van Gogh paintings, and I also have a number of other artists. You can find them on the website. And primarily it has been used for social surveys of different types. All of this is available from the website. Let me now switch to that and get to the live demo. So that's the website, and you can go to news or gallery. This is where most of the applications are. We will go to news, and later on I will also show you the blog, and we will use my service to publish a survey. Let's start with one of the data sets, and the system is not developed specifically for analysis of Sustainable Development Goal indicators. It's just one of the data sets that I happen to load in the system. So from the news page you can start it, and what you will see is icons for different countries. A request to you, you can follow what I show online, or you can actually go to the website and try to click the same links. What you can see is a grid view. These are icons for different countries. On the left, there are indicators that you can look at their distributions. And for each country, you also have information that gives you a profile of all the values that have been computed for this country. The more interesting view is the next one, the bucket view. So here you can look at distributions of countries by any of the variables that you select. So, for example, there is a common, there is an aggregate measure of indicators, SDGI rank, and or SDGI score. It's just aggregate of the scores on each of the 17 goals. And here you can, in addition to this aggregate measure, you can also select any of the measures that have been in the data set. So, for example, poverty, this is the percentage of population that live below $1.90 per day, or you can look at percentage of undernourished, percentage of population who have access to electricity. For each of the 17 goals, there are a bunch of indicators, and you can see how countries are arranged on that scale. I must say that the data set comes from sdgiindex.org website. You can click on About Survey, and that will give you metadata and links to the source. This is one of SDG indicator collections. It has data on 449 countries, and the website creators deserve enormous credit for assembling this data and making them available. This is the baseline data for 1995. There is, of course, a more recent and continuously updated dataset of indicators created by the UN Statistical Commission. Perhaps we shall load this data first, and we can do it together, or you can try to do it yourself. Frankly, when I went to the UN website, I couldn't find an easy way to grab the entire dataset, and publishing this data was a lunchtime project anyway. So this is the bar chart view, and another view is crosstab, where you can select several variables and look at two variables and see how countries are distributed by this, in this table. So let's look at one of the indicators. For example, subjective well-being. How does subjective well-being depends, for example, on poverty level? You would see that there's certainly strong dependency here, but there are also some countries that have a low level of poverty and yet low perception of well-being. So, like in this cell, you can point your mouse to these icons and see that this is Sri Lanka, Bulgaria, Armenia, Cambodia, and other countries. And then there are other countries that have medium level of subjective well-being and high poverty levels, and that would be some countries in Africa, for example, such as Congo, Mozambique, Liberia, and Zambia. So in the same fashion, you can select any other variable and see how it is influencing subjective well-being. You can look at infant mortality or life expectancy or stunting or internet usage, fresh water. There are a bunch of very interesting characteristics here. And as you analyze this, you would see that SDGs appear very complex, and there are all indications that relationships between economic development, social inclusion, and environmental sustainability in each country can be quite unique, and that would point to different development paths as governments are trying to balance their strategies with respect to these key indicators. This ability to look at general trends and distributions and figure out countries' place with respect to other countries, assess progress towards the 2030 agenda, looking at best practices or at similar cases, this is all very important to identifying development priorities. And this is, we hope, where a system like that, where you can visually explore relationships between indicators and groupings of countries, can help. One last view that I want to show is a map view. So we can look at, for example, the same Sustainable Development Goal rank and see where are the countries that are at the top of the rankings. Oh, no, I'm showing stunting. Okay, sorry. Let me switch to a variable that has been measured more consistently. So stunting is not available for all countries. So these are countries at the top of the rank. You can look at where the countries in the middle of the rankings are, and these or countries that happen to be at the bottom of the rankings. There are certainly very strong spatial patterns that you can see. So the idea here is that you can have different views of the data from crosstabs to maps to univariate distributions, and you can switch quickly from one to another. Let me now show you one more way to look at the data. a request that I often hear is that we also want to have some more hardcore statistics. Of course, visual exploration and animation is nice, but can we have some more common statistical measures, such as perhaps compute with R? In fact, one of the options here would be to integrate with R. That would be an additional view that you can expose, and I will show you later how you can add R view. There's also QCA view, qualitative comparative analysis, and this has been mostly used for questionnaire surveys. And but there is something you can still do even with the visual exploration. And the biggest challenge is perhaps to find such analysis tools that will reinforce your visual exploration and vice versa. So, to find such visualization techniques that will reinforce your statistical understanding. So, for example, let's look again at subjective well-being. That's the distribution. I will also show it here on the left side. Okay, subjective well-being, and I will now try to split it into two groups, approximately same size. Okay, and then I can try to see how other indicators would influence, would help me explain why certain countries happen to be in the lower half of the spectrum versus the upper half. For example, I can hypothesize that perhaps percentage of physicians per thousand population, or number of physicians per thousand populations would affect subjective well-being. Let's see, if we have low number of physicians per thousand populations, per thousand people, indeed that increases the percentage of countries in the lower group by 2 to 70%. In other words, we can look at a rule that says that, well, I guess I picked up some additional factors as we've been going, but contribution of physicians is like 13% in this case. Probably I need to reload to show it clearer, because somewhere in as we've been looking through that, I picked up a few additional filters. Let's see, subjective well-being is an indicator for the third goal, and we are looking at subdividing this not into 6 categories here, but we'll just split them in 2 and try to see how some other factor influences that. Okay, and then we can compute the contribution. In this case, the contribution of the lower percentage of physicians is 20%. You can look at other variables and develop similar type of measures. Finally, when you find something interesting, you can click on share, and let's say we're looking at poverty level. If you find that distribution interesting, you can just copy, create a snapshot of this view and send it to your collaborators to, post it on Facebook, put it in a report, and when you follow this link, you will be able to open SuAVE at this same view and continue exploration from this annotation point. I will now switch to other data sets, and talk about how else you can use the system in your work. Before that, I'll go back to the PowerPoint and just show you that we have I've captured some of the screenshots, and you're free to explore them as you review it afterwards. The system has been used in several domains, from public opinion surveys to biology and geosciences and medicine and visual arts and humanities. And about 3 months ago, we opened it up for users to register to the system, upload their data sets, define how this data set should look like when they show up on the web, add metadata, and analyze them online, share the analysis, create annotations, and collaborate with others by sharing views. Some of the common applications are data discovery, where you have, let's say, a large collection of items, or it could be data sets, could be other types of assets, could be let's say projects, and you want to quickly slice and dice them and find what you're interested in. The most common use is publishing image collections. So we've been working with several museums and libraries and who provide these image collections that we publish in a way that you can see the entire collection on one screen. Typically, when such collections are published, you first do a search on certain keywords, and then you observe the results one page at a time. Now it is different because you can see the entire collection. Exploratory analysis, and I will also show you some examples of data curation and asset management, and how you can reproduce and share your findings. So I have one slide for each. Let's say in data discovery, you will be able, this is one example with data discovery, where we have the collection of papers, contributions that have been assembled by the Magnetics Information Consortium. Mostly the examples I'm going to show you will come from the geosciences. In this case, you would be able to zero in on those publications that you want by using facets on the left side, specifying the topics or number of specimens or range of years, look at it on the map, and so on. That works well when you can put enough icons on one screen, but quite often you also have thousands or millions of records. In that case, we have a technology for, and actually a proof of concept demonstration of how you can access such collections indexed in Solr, and once you produce a record set, you can expose this directly in SuAVE. Publishing image collections. Let me show you one example with macrofossils collection from British Geological Survey. And this is probably the largest collection that we have published so far. It has 8,300 images, and together it's maybe 30 gigabyte worth of imagery when we tile it. All of them are here, and as you zoom in, you can you see that the images get sharper because this is tiled representation. You can also select, you can browse it in this way. For each image, there is information. There's some metadata, and you can use this metadata to subset the images that you want. So, for example, this is everything that is under Insecta, and let's say you select an image, and as you zoom in, it can get you can get much higher resolution. Then if you find something interesting about this specific image, or you want to correct metadata, you would click on comment, and that will open a commenting view. So now you would type in some comments, and then this information will end up, if you are a curator, you will be able to see that. If you are the author of a data set, you can expose your data sets in a way that would invite other collaborators to look at the data set and share their analysis with you. Yes, okay, let's go back to PowerPoint. Another interesting example is wetlands in the lower Mekong. And this is a multinational project that collected a lot of soil samples. For example, let's look at types of photos that will show us layers of soil collected. As you zoom in, you would see that these are actually, dependent on the network to update the images. So it may take us, yeah. So you would see that these are photographs of soil samples. You can try to see how they would be different for different types of river connections or types of systems. So I would use lacustrine and riverine systems, and I can now compare different systems, perhaps subset this further by water depths, and you see how it works. You can look at the whole range of factors, use this to zero in on images that you're interested in, and then visually compare them. So perhaps look at the texture and color and see how it is different across, under different selections. Moving on. The project funded by NSF focused actually on analyzing surveys, and we thought that this approach would be much more engaging and kind of inviting for analysis than when you traditionally have to deal with tables and standard charts. So one example is a survey, and this is a snapshot of, let me close these things, General Social Survey. So General Social Survey is something that is conducted in the US every 2 years since about 1972. It reflects, it gives a representative sample of US population, and they requested to answer all sorts of questions. So, for example, one question is happiness, and now I'm typing into the variable search to subset the list of variables that I have. And that is, now you can see a distribution of responses on questions to general happiness, from very happy to not too happy. And then you can hypothesize about what kind of factors would be influencing this distribution, such as education, for example. So you're looking at highest year of school completed. And indeed, that does affect level of happiness. So from 26%, you now get to 31% in the group that is very happy. If we remove that and switch to something else, let's say highest year of school completed by a spouse, that actually has a much more dramatic effect on being very happy. So if you are married to a spouse with 15 years or more of education, then it's much more likely that you will say that you're very happy then compared to your own education level. And then you can again compute contributions of each of the factors to this behavior. You can, it's an online data set. You can play with it and see how this relationship would be modified by gender, and find a few other interesting things. I will just move on to some additional examples now. Let's see. Yeah, so as I said, you can use the system to do data curation with an example of BGS macrofossils collection, where you can annotate a sample, and then you would accumulate a list of annotations in your collection of annotations. Here is a view of my personal gallery. I have about 73 surveys published, and I also have a bunch of annotations. Some of these annotations, or one of these annotations, came from the item that we just looked at. So you can organize this by data sets that you are looking at, and essentially assemble a list of notes, a list of comments about your data set, and then use it to improve it. So another example is where once you can annotate your data sets, you can also you can annotate individual pieces, or you can annotate patterns. For example, in this case, we can say that this is the pattern that we have. We can save this pattern and share it with others. And then when we describe our analysis of the data set, it will be essentially a stitched sequence of annotations like that with explanations, and that would allow you to demonstrate your pathway through a data set as letting other people to reproduce your analysis and follow you, so that from each annotation point you can jump back to SuAVE and see what happened, and perhaps take the analysis in other directions. One example is in the blog page, where I looked at results of an election survey in an attempt to explain what happened with public opinion, with horse race polls that happened to miss the results in the last U.S. elections. And again, this is a sequence of analysis steps taking you through American National Survey election survey pilot, where from each statement you can jump back to SuAVE and see what happened. The last application is community building and crowdsourcing. Derek mentioned at the beginning that there are lots of people in Iron Earth. Often you don't know them, and it would be interesting to see whether you have matching research interests, figure out where people live, what they are up to, and this is an example that we have done with University of California faculty who are working with partners in Mexico. So you can see that it can be a gallery of people. Again, as you zoom in, you can look at the faces, and you can look at their research interests. And what is interesting about this gallery, well, of course, you can sort this in the same way as we would sort any other SuAVE data sets. So these are, for example, folks from Berkeley, San Diego, Davis, and we can also subset this by people who are interested in, let's say, environmental issues. But also it's a way to crowdsource this information. So here I would click on edit profile link, and that will allow me to, if I have sufficient credentials, in this case I am the administrator, so I can log into any of the records, but it takes some time to load. Okay. So login. Now I can edit profile, and that would allow me to update the image or edit research interests, fill out other information on the forums, and that will update instantly this collection. So imagine that something like that can be done for INRs, where you would have research interests of people who are involved in this initiative, and figure out where they are, how you may engage, what kind of teams you can form. Going on. Oh yes, and Derek mentioned that we have this for the webinar. These are data from I believe Monday evening, when we had 272 registrants. You can see that yes, you can sort this by any variable. Of course, you may try to see what is the relationship between, let's say, people who are interested in data issues for natural environment and people interested in built environment. And there are certainly groups who are very interested in one and not interested in the other. And you can see which countries they represent. Or you can look at distribution by countries, and let's say I will select those countries that have the highest number of registrants so far, and see if the percentages here would be different for, let's say, those interested in data aspects or data issues for natural environment. Those who are interested very much, you would see that, for example, the percentage of Italy goes up from 10 to 16%. You can look at Italy only, and then you can also see which organizations fall into this group. So let me just uncheck that and look at Italy only. So you would see that that's mostly FAO and a few other groups. So not surprisingly, there is a strong interest in data issues for in natural environment. And it's been also used to teach classes at UCSD and in some nonprofit projects. I will now very quickly show you how you can publish a survey in SuAVE. I'm conscious that we are, yeah, it will take me like 3 more minutes. To do that, let's open, yeah, once you log in, you would have your personal gallery. And this is my personal gallery. If I want to create a new survey, I would just say new survey. On the desktop, I have a file that, where is this? No, not this one. Okay. Yeah, test. So that's a sample file. It's not really a sample, it's a survey of EarthCube members. You see that this is a standard CSV file that has variable names and responses. And the way to publish it is actually quite simple. So I point to this file. It's on the desktop, and that's the name of it. It's about 3 megabytes. I'll give it a name, demo survey, and that's pretty much it. So that will create a new record in my gallery. I can start editing this record, and well, I could add a map, or I could specify which variables I want as the variable that will appear as the name of it. I can associate shapes. For example, gender. A variable will show me different icons for different genders, and primary discipline will be shown as different colors. So geosciences will be this color, and you can choose colors yourself. I'm not going to do that in the interest of time, but once you click submit, this information will be saved, and you will be able to then click on the data set and show it on the web. And now it has a URL. It has all these, you see that the silhouettes and colors reflect variables that you select. And there were quite a few interesting questions here, such as how important or how easy it is to use different types of data. And you can look at distributions and see what's and make some conclusions about it. So all the functionality is available to you from this one. In addition, you would be able to, let's say, select what should be the starting view. You can define metadata for this data set, and you can also edit variables or edit data sets. So in this case, I only have some open-ended questions that I specified as long questions, and otherwise there are no modifications to the data file, to the CSV file. This is pretty much all I wanted to say. The project is it's an ongoing project. We are still working on making it more robust and figuring out bugs, and there are some plans of how to extend it. But if you are interested in how it works, please get in touch, and we have now more than 50 external accounts, so you're welcome to create an account on the system and publish your own data. Thank you very much, and these are the acknowledgements. I will stop here and wish you all Happy New Year and take questions.